Flattening a linked list is one of the most interesting problem on a linked list. It's a GFG problem. I will provide you the problem link into the description box so you can directly jump from there. It's, it's mostly asked in an interview. Whenever interview asks you this problem, they basically want to check how deep knowledge you have on a linked list. GFG is a medium level, but I think it should be around medium to hard. So let's deep dive into the problem. So the problem is stating that you have given the head of a linked list. You have given the n head nodes, means every node is a linked list itself, and you have to flatten it. You have to flatten the whole linked list in such a way they should be in ascending order. I mean, our the final linked list should look like 5, 7, 8. After that, 10, 19, 20, 22, 28, 40, 45. They should be in ascending order. So you have to flatten in such a way our final linked list should be in ascending order. So, and it say my every node contain two pointers. First pointer pointed to next element, next which will the same as other linked list. So next will be pointed to next node, and there is a one more pointer bottom which will point to the bottom nodes. So for node 5, there will be two pointers. Next will be pointing to the next node, and the bottom will be pointing to the this bottom node. So you can see this node, I mean this 5 node is the head of this linked list 578, and the head of the other linked list. Same for the 10 is the head of the 1020 linked list, this one, and same for 19 is the head of this linked list, and same for this the last one 28, 40, 45 is the head. 28 is the head of the this one. So every node is a head itself of this linked list, you can say. So you basically have to flatten it. I mean, you have to make a single linked list where the every node in the ascending order. So you have given two pointers, next and bottom. So how should we will approach it? Let's move to our Excalibur row. So you have given a linked list, not linked list. Yeah, it's kind of linked list with two pointers, bottom and next. So can I do? Can I think? Suppose if I merge, and one more thing I have to say that every linked list they should on the bottom they should be already sorted. They are already sorted, so they should be sorted. They are sorted. They are sorted. This one is sorted. Same goes for 1922, and same goes for any other nodes or head. They will be sorted. So so if they are sorted, okay, can somehow can I merge these two linked lists? Right? I have already uploaded the merging video. So you can if you can merge this linked list into a single linked list. So after merging this linked list, you will get a single linked list. And again, you can merge this linked list with that merge linked list that we will obtain after merging these two linked lists. Okay. Then again, can we merge this linked list with the merging of this part, this three linked list? So I think you are getting the point. So what I will do, I will keep calling the same function again and again. I will keep calling the same function flatten again and again until I reach here, until I reach the last node. And I will, when I reach here, I will say, can you merge with your next node? Because the next node should be the head, I mean the linked list itself. But in this example, there is no next, it should be null. So if you merge with a null, it will remain same. Okay. After that, it will return this linked list because it's already sorted. Like I said, every node Every head of this node is already sorted. So this is already sorted. So you can simply return it. You don't have to do anything. So it returned this node, it linked list. After that, when you reach here, can you merge these two linked lists? Yeah, I think you can. How? I will tell you later how. So if you, I mean, you merge it. You did merge these two linked lists. After that, you got a single linked list. Then again, can you merge this linked list with the merging of these two linked lists? Yes, you can. So again, you got a single linked list with the merging of these three. A single linked list containing 10, 19, 20, 22, 28, 35, 50, 60, 70. Okay. So again, can you merge this linked list with the merge part of this three linked list? Yeah, we can. So that will be our whole intuition. Okay, so I got it. I think you're getting. But how we are merging it? Suppose you have to merge these two linked lists, the last one, because there's nothing, there's null. So merging this linked list with the null is the same as this linked list. So so you have to merge these two linked lists. What we can do, we can put two pointers A and B here. Okay, two pointers A and B. If my A is smaller, I will do, I will create a node result, and I will say result next, can you point to the A? So my results become A. After that, I will say result bottom. Can you call the same function again? But this time, what you have to do? You have to move your A to the bottom. Now you are comparing this A with the B. Then again, we will check if my A is less than B or not. So again, it's a less than A. So again, call the same function merge, but this time you move A to the bottom. A to the bottom. So A again moves to the bottom. So again, you do the same thing. You call the same function A. Is my A less than B? No, it's not. So what you will do, you will went to the else part and you will say result becomes B. After that, you move result B. Then you connected result bottom to the same function, but this time you are moving B to the bottom. You're moving B to the bottom. And again, you'll keep doing my key. My B is smaller than A, so again you move your B here. Then again, my A is smaller than this time, but A reaches the null. The moment my A reaches the null, what you can do, you can simply return the B from the B, because if my A reaches null and there's some part on a B, they are obvious that they're gonna be greater than the A, the previous, 50. Because if the A reaches to null, I mean my B is gonna greater than 50. So you can simply return this node or whatever the node are below the B. So just connect them and return it. So it will be looking like something this. Our result linked list should be written like this, and you can simply return the result. So 19, 22, 28, 35, 50, 60, and 70. Again, you got this linked list, this one with you have to merge with this part, and we already have flatten it. So now you have to flatten this to linked list. Not flatten, you have to merge this to linked list. So what you will do, again you will do same thing, A and B. If my A is smaller, you move A to the bottom. If B is smaller, you move B to the bottom. Call the same function, but with B to move the B to the bottom. Okay, so that's what I have written here. Result, I have took our node result. Then I am comparing, if my A is smaller, then result equals to A. Then call the same function result bottom. I'm connecting. I am saying result bottom. You should be the merge function. with A or bottom. Means my A is smaller, so I move my A to the bottom. Else, if my B is smaller, then I'm doing with the B. And what is this part? Result next should be null. We don't need they should point into the any other value because we want a single linked list, right? They should be pointing to null. Every node should be pointed to its next should be pointed to null. So keep that in mind. Every node next should be pointed to null. Even 19 next should be pointed to null. And after that, you can simply return the result and keep doing it. So let's try and run it. What we done exactly? Okay. So in the first time, okay. So in the first step, I call the function with this node. Is next. Where is my code? So, okay. So my root next should call the same function. So my root of 5 called for this flatten of 10. Then again my flatten of 10 call for the flatten of 19. Again my flatten of 19 call for flatten of 28. Then again my flatten of 28 calls for the its next node, which is null. If it's null, flatten of null, you can simply return 28. I mean, you return this linked list. But when you return this linked list, you have to merge these two linked lists. Remember, so when you are returning this linked list because it's already sorted and this is already sorted, so you have to sort two sorted linked lists. So after merging, it will return a sorted linked list. So again, you have to merge two sorted linked lists. After that, it will return a single sorted linked list. So now again, you have to merge two sorted linked lists. So now let's move to our GFG and try to code it up. So let's see. I know it sounds super easy, but it's not easy. So what do we need? Like I said, root of next. Root of next should be calling for what? The same function. It should be called for same function until we reaches the last node, that is root of next. After that, when this function returns, you have to merge it. Okay, remember. So I will create one more thing. Let's call root equal to what? Let's call a function merge with which will merge two linked lists. So it will take root and next of root. In the first time, if my root is the last node, the next of root will be null. If it's null, merging with null will remain the same. After that, what do you have to do? You have to return the root. Simply return the root. But we didn't put our base condition. Even if reaches a null, we are not stopping. We keep calling, and at some time it will give you error like accessing the null pointer. So you have to give a base condition like if what if my root reaches to the null? You have to stop there. No need to go further. So if my root reaches to null, just stop there. Or my root next of my root reaches to null. You have to stop there. I mean, if it's my last node, you don't have to go further. You can simply return the root. Okay. Now let's so this I will calling the root next of root with a flattened root next of root. I mean, reaching here, this call this 10 will call for 19, 19 will call for 28, 28. The moment you went to the 28th, there is nothing null, so you can simply return the 20th from here. I mean, you return this linked list from here. After that, you will merge it. So let's merge it. Let's call a function called node strict merge. What it will take two parameters, not least node. It will be a type of node. Let's call it a, which will point to the root, and I need one more pointers that will Node of B, which is pointing to the is next. My A will be pointing to 19, my B will be pointing to 28. Everything is good till here. In this, what I need to do, I have to check if my A data value, yeah, data, if my data of my A, if it's less than data of B, what you have to do, you will see result can you become A, and I will my next of I mean my bottom of next result will be what? The same function, but this time my A is smaller, so I will move my A to the bottom and calling with the same B. Else, else I will do the exact same thing, but this time with the B. Okay, so I will go here. I will say B and the same thing for B. After that, you can simply return the result. But no, you can't, because you have to, you have to point the node next to be null. So you can simply say result next. Next of result, can you become null? Because I don't need it, null ptr. Some will say I'm using null ptr and null. They will do the exact same thing. So you can use capital null here. It's all up to you. And after that, you can simply return null result, not null. But where is my result? So let's create result. So node asterisk result. But again, we didn't put our base condition, so it's gonna run infinitely. So you have to put your base condition because it's keep going calling merge and merge. Even if switch is null, you're gonna keep calling the merge and merge. So you have to give something a base condition. So what if my A reaches to null? So if my A node reaches to null, what do you have to do? You can simply return B, because if there is nothing on A, so return B. The same for the B. If my B reaches to the null, return A. I will explain it in detail. Okay, what I'm doing. Suppose my A will somewhere here, my B will be the null. If my B is null, you can simply return this now. Are you getting? A is here. A was on last node. My B will be pointed to null. If B is null, directly return this value because it's already sorted. So that was the whole thing. And what if my B is null? Suppose somewhere, suppose there is only one null, and it suppose my A is here, B is here. If this value is null, which can't be, so you can simply return the B in that case. So I think we have written the whole code. Now let's submit it up. It says comparison error because return. Okay, where I am doing wrong. Line number 25. It's not return, it's result. I'm a human bro too. I did mistake sometimes, so don't need to. Now I think it should be, but still I have done something wrong. Where? But where? Line number 25 is still saying result bottom equals to merge A with the B of bottom. Am I doing something wrong? Where I'm doing something wrong? Okay, line number 25. I was seeing line number 20, so it's my bad. So it should be result, and I think it should be working. So let's submit it up. I think it should be was submitted. So for the Java, I have copied the whole thing, the same thing, and pasted here, and I have modified the same thing already. In the Java, we don't need asterisk, so I have removed all the asterisks. In place of null ptr, you have written the small null, and in place of arrow operator, you have put the dot. Here dot data is less than b. If my a data of a is less than data of b, you did the same thing. Result equals to a. Then you call the same function with the bottom of a with b. And again comparing the same thing. If my data of a is less than data of b, we did the same thing. And in the flatten function, we did the same thing again. And after that, we return the root. So that will be the Java solution. You can check it out. And for the Python solution, is we did the same thing, but the syntax is a little bit different from the C++ and Java. In Java and C++ are both identical in some way, but Python is a little bit different. So if not A is the same thing as this one. If my A is null, return B. I have done the same thing. If my A is null, return B. If not A means if my A is null, which is false, not A becomes true, then if my A is basically it means if my A is null, return B. If my B is null, return A. We did the same thing. And the same thing again, if my data of A is smaller than data of B, then do the same thing, result and the same thing. But here will self, you will see a keyword self. You use self because in the main function they have given the self and root. So that's why whenever you create the function, you have to pass this instant. It will help Python to identify you are calling this method on this instant of the class. So this basically means you have to pass on a self.merge. I mean, we did the same thing like merge A or bottom with a B, but you have to put self dot this thing in the Python because in the main function they have given the instant of the class. So again, we did the same thing. Call the flatten function again and again until you reach the last node, and yeah, it's working exactly fine. So what will be the time complexity? What we are doing, we are calling the same flatten function n times. If my there's an n node in the linked list n head, so it's calling n time. After that, coming back, we are merging it. In the merging, we are keeping a pointers, b pointer, and merging it. Just merging, taking around the size of this linked list plus size of this linked list. Suppose and then in the worst case, they are n. So from there is coming to n, and flattening calling keep calling it, so it's taking n again. So time complexity will be big of n. What about the space complexity? You are calling same function flatten n times, so it's gonna take big of n recursive base space. So the space complexity will be big of n, and the time complexity will be big of n. So that's it for this video. So if you like my video, do subscribe it.